Coming up, my honest review of the Bluetti EB55 portable power station. This is the baby in Bluetti's range, okay? It's a battery in a box with an inverter and numerous power out options. It's affordable, simple, compact, lightweight, all of that stuff. You get 240 volts of household type AC electricity out, numerous USB ports, there's 12 volts of DC like the car stuff, plus an inductive charge pad for your phone. I've been using one for about a month now, and here's my honest assessment. I'm John Cadogan from AutoExpert.com.au, and I get new cars cheap for buyers here in Australia. Website for that, SC, or you can just click the card that's, up there now, dude. Let us lift the skirt gently and take a look at what makes the EB55 tick, and then perhaps see if it's the right portable battery baby for you. And before we get into the review, let's just do the full disclosure bit, okay? Bluetti sent me an evaluation unit for free, but they are not seeing this review before it goes live. There is some criticism in this review, but they're not having any input into any of that. And certainly no money changed hands. In these respects, this is the same as a car review, only obviously you tend to give the cars back after a week. If companies send me stuff, essentially, and I think it's kind of hopeless or underdone in the design, I just decline to comment on it. So this is what I really think of the EB55. I should also explain that I'm doing this review today because Bluetti has a sale on right now, and it's going to wrap up in 2 days' time on the 14th of March. And the discounts are significant. If you wanted to take advantage of that, act now, okay? Details in the description, and if you order one of their products using any of those links, I am going to get a small commission out of it, and that's going to help the channel, but it's not going to cost you any extra. That's the full disclosure. This episode is not sponsored. I'm not getting paid for this content. The EB55 is massively discounted right now, though, at roughly half price. It's $849, which is down from its normal recommended retail of $1,699 Australian. And the big brother, the Expedition and Hardcore tradie-friendly AC200P, which I have reviewed separately, and I'll try to remember to put, link up there, dude. It's also on sale right now at $2,399 Australian, down from $3,299, a saving of about $900. And speaking of the AC200P, Bluetti and I are giving one of those babies away to one of you, and we're doing it right now. In this case, to a dude named Igor Puskaric. I hope I got that right. From Kings Park in Victoria. I'd have to say thank you very much for reaching out, Igor. I jumped in the shower yesterday for my weekly catch-up with the, let's call her the Executive VP of Giving It Away. And after some brief but intense deliberation, we jointly concluded that you were the winner, Igor. I give you 13 points out of a possible 10, son, for exposing your grandkids to the real world. Not too many kids get that anymore. And I certainly hope the AC200P assists you on those excursions with the next generation, and also when the power goes down at home. Well done. And thanks, of course, to Bluetti there for setting this up. It's the biggest giveaway I've ever done on the channel. Igor, your AC200P is on a truck, and you should see it soon. The EB55 is quite new in Bluetti's inventory. It's Bluetti's smallest portable power station. It's a brick containing 537 watt-hours of lithium iron phosphate battery, plus an inverter, a control system, and power in ports for recharging and power out ports for use on location, essentially. It's also the baby in the range, okay? And from here you can step up to the EB70, with just over 700 watt hours of onboard energy, the EB150 with 1.5 kilowatt hours, and the AC200P, which I've reviewed, with 2 kilowatt hours in total. So it's definitely going to pay you to consider carefully both the amount of electrical energy you need remotely and also the peak power draw requirement so that you can pick the right unit for your particular application. The EB55 delivers a maximum of 700 watts, meaning that's how fast you can extract electrical energy from the battery. And just to disambiguate that, because power and energy, so confusing, power in watts is the time rate of energy discharge. So 1 watt is 1 joule per second. 1 kilowatt is 1 kilojoule per second, essentially. A 700 watt appliance is a fairly substantial electrical thing. Here's a hopefully half interesting exercise. You're familiar with the drill press, you see it all the time on the channel. There's the EB55. Here's a piece of 50 by 12 rectangular flat bar. It's just hot rolled, regulation, low carbon steel, like 250 MPa, minimum yield stress, mild steel. And certainly this is up the cheesium end of the steel spectrum, but still you'd work up a sweat if you were going to drill through it by hand. I've got an 8.5mm drill set up in the drill press, and that's relevant because it's a common size that you get in a box of drills generally, and it's also the tapping size for M10 cores. So if you wanted to put a hole in this piece of bar for a reason and tap it for M10, this is exactly how you do it. So I've got a block of wood set up here just to minimise the punch through, or to stop the drill grabbing a little bit when it punches through. And I've got the vice grip set up to give me clamping force. And pro tip for drill presses, okay, I'm going to put the non-drilled end of the bar against the column, and that's going to provide counter-rotation sort of resistance in case the drill grabs on the way through. And all I'm going to do then is plug in the Bluetti and see how it goes. Now, notionally, this is a 1 horsepower motor, okay, which is 750-ish watts, 746 if you're a pedant, but I don't think they can make them that accurately. That's when the motor's doing its hardest possible work, however, and I really don't think we're going to be doing that with this. This is just a regular high-speed steel twist drill, okay, with a 118-degree grind point on it. Nothing clever about the point. It's not a split point. It's just got a conventional chisel point grind, and I'm going to punch through it without spotting it or any of that stuff. But just for shits and giggles, I will use a little bit of Trefoil X HD, mainly because I love the label. The thick fluid sticks to the tool. And I think, you know, deep down, we all want a little bit of that from time to time. Okay, so that was pretty painless, I think you'd agree. It was just like using regular mains electricity, wasn't it? Although I would say maybe there was half a second or so worth of additional lag between the machine being dead stopped and achieving its full operational RPM. And I don't know if I'm just imagining that or not, but that's how it seemed to me. Anyway, but we've got a fully functional 8.5mm hole in 12mm of steel, just right to be tapped for M10 if that's what we want to do next. And if you look at the peak power draw during that drilling operation, it was what, like mid 400s or something. So we've actually got more than an hour of drilling time, and I don't mean set up and marking out and all that stuff. I mean actually turning and burning and plunging the bit into the job. We've got more than an hour of operational time like that before the battery runs dry and we have to recharge, which is a lot of work when you think about it, particularly considering the compact size of the unit. There are a total of 10 output ports on this device. You get two 240 volt AC GPIOs, like the power points at home, plus a regulated 12-volt DC 10-amp Siggy lighter type port, 2 additional 12-volt 10-amp DC ports, 4 5-volt 3-amp USB ports, and 1 high-power USB-C port capable of up to 100 watts of electrical supply, which is sufficient to fully charge a flat MacBook in 1.5 to 2 hours, depending on the actual model of your MacBook. That's 10 ports all up, plus there's an inductive charge pad on top that delivers 15 watts. So you can just randomly chuck your phone on top without having to plug it in. And you can use all 11 of these power outlets at once, or as many as you like, provided the total power draw does not exceed 700 watts, in which case the unit is going to protect itself by shutting down. It's actually surge protected to 1400 watts for brief periods, and what that does is protect the device from damage if you connect something that draws current heavily on startup, like briefly. These would be things like fridges and power tools. You know how the lights sometimes go dim when these things kick in? Angle grinders have to overcome the inertia of the grinding disc, for example. So you don't have to worry about it being especially temperamental in environments or usage cases like that. Here's a test of the EB55's ability to tolerate power draw on startup, like surge on startup, okay? This is a 4.5-inch Bosch angle grinder. Now, it's rated at 720 watts, which is just outside the 700 watt envelope of the EB55. But you've got to remember that power tools only draw their maximum power when they're being used as hard as the designer ever anticipated. So if we use the grinder with sort of mechanical sympathy, we should stay inside the 700 watt envelope. However, this has got a big heavy wire wheel on it and it spins really fast and it gets up to speed really fast. So when you turn it on, it's going to draw a lot of power quickly to get up to speed, and then the power is going to ramp right back to its sort of steady state operational, less than 720 watts kind of thing. So this is a piece of just rusty old off-cut channel that we'll clean up just for giggles. And without further ado on all of that, as Jean-Luc Picard says all the time, energize. So it seems to me that even though the tool itself is rated at 720 watts, that in practice for a job like this where we're cleaning up a bit of rusty steel, we're still only drawing about 400 watts out of the unit. And in terms of time, actual rotating, doing the job time, that means with a full battery here, we're looking at well over an hour and a quarter worth of actual grinding. This is not changing and clamping and replacing whatever, discs or wire wheels. This is just head down, glasses on, doing the grinding, okay? And that's a hell of a lot of grinding. It's more than enough to make you sick of grinding. And I know you could use a battery grinder, but the only problem with that is if you've got a lot of work to do with a battery grinder, you need a stack of batteries this high because battery grinders are just not that durable in terms of the amount of power that they suck out of the battery. It is a fairly energy consumptive game, grinding, right? So it makes sense to be able to plug in if you've got a lot of grinding or similar work to do. And the EB55 clearly extends the durability, the endurance, whatever you want to call it, of that kind of operation. And from a surge tolerance point of view, I think it's worth its weight in gold because there's no hesitation, the tool starts up really fast, and it is difficult to get from whatever it is. You'll have to excuse me because I won't be able to read it unless I put these little bifocals on, but from 0 to 11,000 RPM, like 6,000 RPM is 100 revolutions a second. So this goes from 0 to nearly 200 revolutions a second in the blink of an eye. And the unit tolerates the surge type power consumption to do that easily. As for powering the whole thing up for recharging, it comes standard with one 200 watt AC power supply, like a plastic brick. and you'll be fully recharged in just over 3 hours if you use that. And like all batteries, the last 25-ish% of the energy capacity takes the longest per watt hour to pump in. You can actually buy yourself a second AC charging brick, and you can use both of them at once if you need faster turnaround times for your EB55, but it's probably not necessary in the majority of cases. A 200-watt solar panel can be used as well, and that'll do the job in about 4.5 hours, provided you've got adequate photons feeding your solar array. And you can use that together with a wall outlet if you've got one handy, okay? So they can both be used together. Or you can plug the EB55 into your car's 12-volt DC supply, and you can recharge on the run in about 6 hours or so. Or you can do it in 3 hours if you're in a truck and you're feeding it a 24-volt DC supply. The EB55 weighs in at just under 7.5 kilos, so moving it from the campsite to the car and from car to car is dead easy. And this is a distinct advantage compared with the AC200P, which is the heavyweight, literally in the range. It's about 20 kilos heavier than the EB55 and definitely hard to carry any significant distance for most people. Like, the AC200P has a lot more electrical grunt, so fair enough, batteries are fairly heavy things, but if you just need a little bit of auxiliary electrical power, the AC200P might be kind of overkill for you. I guess you could just buy the AC200P and then cancel your gym membership and even things out. And certainly you'll be doing enough weight training. Bluetti says that you should expect more than 2,500 charge cycles to 80% on the EB55, which is 3 to 5 times more cycles, they say, than other lithium-ion battery chemistries, and that's probably thanks to the lithium iron phosphate construction. That's iron, as in Iron Man phosphate construction, okay? They're also safer in terms of resistance to and severity of thermal runaway events if they get damaged or overheated. So that's a consideration also. Nothing containing energy is perfectly safe, however, and anybody who tells you that it is an idiot, like 50 litres of gasoline. Now, to me, the real advantage of these kinds of devices is their portability and the fact that they're a turnkey remote power solution. So someone else has already done all the hard work in R&D. And you can swap them from car to car or from vehicle to vehicle dead easy. It doesn't have to be car to car, it can be car to caravan, right? Like if you're a tradie, for example, and you've got work in the boonies from time to time, you can recharge about 6 18-volt 5-amp-hour power tool batteries without ever firing up a generator. More than that, if you've got a solar panel upstairs on the roof of your ute or your canopy and the sun is shining. Or you can run a grunty 240-volt plug-in power tool up to 700 watts from time to time if the job you're on demands that. And you don't need a wall outlet at any time if you're working on some shed on a property, right, or something of that nature, cabin in the woods, whatever. And if you want to take the family camping at the weekend in a different 4x4, no problem. You just move the EB55 from ute to wagon, right? And you're good to go. The same thing if you've got a caravan or a boat. Like, there's your 240-volt supply solution for the van or the boat if you need that. And with all of these applications, you don't have to do surgery on the vehicle and then mix and match a bunch of components which you arbitrarily hope are going to ultimately play nicely together electrically. Batteries and inverters and isolation switches and things of that nature, as well as finding physical real estate within the vehicle to install these things safely. And then you've got to live, of course, with the fact that installation is hardwired and therefore your solution is not portable. And I'm not taking the piss out of DIY here or aftermarket solutions of that nature. They are absolutely right for some people. Maybe they're better if you're going to live in a vehicle for 12 months and be a proper grey nomad or something. But On DIY in particular, I'd suggest that there are safety implications when you mess about with this much energy. So you would definitely have to know what you are doing if you want to DIY it. And even then, the problem with most DIY, I'd suggest, is that owing to most people's budgets and their time constraints, every finished project tends to be a prototype. And even a good prototype done by an expert is never as good as the third or fourth design iteration. Like, it's just not. Whereas these units, like the EB55 and its bigger brethren, they're well thought out and ready to rip out of the box. The courier delivers it, dude. You plug in the charger and then 3 hours later, you are good to go. And the value proposition is great, especially for the next couple of days during the sale. I'm actually running the main studio key light, just here, this big, bright, softbox jigger, on the EB55. It's an Aperture 300D, like a 300 watt chip on board daylight balanced LED, and pretty expensive too. You wouldn't want to mess with it. It's been powered up using the EB55 for this entire shoot, and it's all up and running, I guess, for about 45 minutes. That light is actually pretty grunty, and also a fairly delicate piece of electronic equipment and expensive to replace, okay? And it's, as you can see, it's fine. And also, there's no strobing or other flickering kind of artifacts coming from it, which tells me that the inverter on the EB55 is doing a pretty solid job converting DC in the batteries to a high-quality sine wave version of AC. So that's nice. You can tell that the inverter is a premium product based on that. The verdict, after using the AC 200p and now the EB55 fairly extensively, is that there's really no point cobbling together your own battery inverter system and hard wiring it. Like, at least there's no benefit for most people. However, in the interest of full disclosure here, you do have to be a bit careful about not blocking the cooling airflow through these units. I'd be taking that quite seriously because you really don't want to be overheating anything with batteries inside, okay? There's nothing in the literature also about water resistance or even splash resistance. And I'd suggest that a slight improvement in ruggedization there might be a welcome inclusion perhaps in future models and even broaden their appeal to a wider market of users, given nothing more than the environmental slings and arrows that the real world can throw at you from time to time when you're out there communing with nature. So it's up to you to ensure that the unit stays dry. And the other critical thing for you to remember if you are going to use one of these, and this is not a design deficiency at all, it's a you not killing yourself thing, is that the 240 volt outlets in these things are real. They contain more than sufficient power to overwhelm your external skin resistance and kill you. And I'm not being melodramatic, okay? So all of the normal safety practices, which are prudent with outdoor AC power, and AC power generally, to ensure that you do not wake up dead one day, like, they certainly apply with these portable power stations also. Do not become complacent around systems like this because there is a lot of energy and a lot of power involved, and you certainly can hurt yourself if you don't consider that. I can certainly recommend the EB55 and the AC 200p to you without reservation, having used them both extensively now. They're quality units and I've really enjoyed using them. They've been awesome and reliable for me. They're great value too, especially during the sale, which is running for the next couple of days until the 14th. Links in the description. Thank you very much for watching.